Hello, everyone. This is Jeff Wilkerson, professor of physics at Luther College. Today, we're going to talk about sort of basics of data file manipulation in KaleidaGraph. So this is largely for the Physics 182 students here at Luther College, but if anyone else finds it helpful, that's great too. So you see I'm sharing my window with you today. This is a data file. I've made a copy of a star data file that for one of the stars that we study here. And so we'll just go through a few things very quickly. You can stretch these or shrink these columns by grabbing and pulling on them. If you want to make them wider or narrower, you can change the header. If we didn't like day overall, we could change that to day. Click back off there and you see what that is. So you can see how we can sort of arrange this as we like to see it. I have this down chevron clicked so I can see column numbers. We won't do formulas and formula entries in this video. We'll have another video for that. But if you wanted to use formula entries, column numbers is the way you would do that. And so those column numbers are important for you to know if you want to manipulate the data. So we're just going to walk through these three pull down menus up here. We'll start with data right here and look at some of the things that we can do. So we can append columns. And so I could add columns out here. I could add 100 columns at the end if I wanted to. And there they all are. So we have a lot of columns out here. I can add rows. Data, I could say, let's add rows to the bottom. 100, sure. We could add more. I don't remember what the limit is to what you can add here, but I've added lots and lots and lots of rows to many of these data files because I have very large data files that you see with lots of data. We can come up here and we can insert a row or a column. You can delete a column if you didn't like that column. But let's say, suppose we had data. We don't have data for 2004, but suppose we figured out we did. I can right click on it and I can pull down from the data header up here, or I can right click on that column and say, let's insert a column, and it will insert to the left there. And then I could come up and say, hey, let's do 2004. Bingo. We've got what we want. Now, what I'm going to do is I'm going to do it, and I could do the same thing. If I did an insert row, I could insert a row right here and say it'll insert the row above it. There's that row above it. Oops, I don't like that. I'm going to delete that row. Boom. Okay, so you see the kinds of manipulations we can do there. What I'm going to do is a Control K, which is the same thing up here as data column formatting. So if I grab that column right here and do a Control K, you see that it says it's float general 5. So you look at that, you'll see, oh, there's 5 digits. Float means that it's a decimal point number like that. And we could make this 8 digits and apply it. You always have to apply it at the end. And there's more digits out there. Probably those digits, I don't know if those digits are stored in there, if they have any meaning at all after the calculations that we've done. You can show the zeros that come after there if you want to or not. I'm going to go back to 5. I like the 5 a little bit better right there. Let's look at the new column we just made. Float general 5 is what it is. Let's go over and look at this column, float general 5. Let's look at this column. That's an integer. That makes some sense to me, is to say that we would have that integer text format. That could also be date format. You could choose that to be date or time or something along those lines. I chose text in this case for whatever reason when I built this a long time ago. But if you chose a date format, then you could select the format, the sort of format that you want for the date. You know how you like to arrange your dates. And so anyway, you see here we could actually change the column width in here. instead of dragging it like we did before. So there's different ways to do a lot of this different stuff. You can change the text color in there. You can change the style of the text that you have in there. So there's a lot of different approaches to things that you can do right here. So that's the sort of different data formats that you could have. One that I do use actually once in a while. I don't use it that much because our data is not that good, but I might want to make that double precision. So if I make that double precision, that means that I have more digits of precision out here, more decimal points that are stored in the data file for me to do calculations with. So there are times when that's important for me. So you might want to use the double precision out through there. If I come over here and stretch that, I don't know if you can. I stretch that like that. You saw that change to 135. I can stretch it back down to 77. So you can see what's going on there. Red. Okay. Apply. So there you go. We just made that column red for whatever reason. You don't have to make whole columns that way necessarily. We could do this, and we could say, let's make that blue. Oh, it did make the whole column. I guess you do have to make the whole column that way to do it this way that we're doing it here. So anyway, we can make different values like that. And so way to format your data, way to look at your data in there. So you can close that up here. I think that's pretty much everything I use significantly in the data in the data pull down menu. There are the other things I'll use from time to time, but from this basics, let's not deal with that. Sort of functions. The only few things that we're going to look at in here is you see that we have data masked out right here. And so we will mask data. If there's data that we don't want to use in calculations or we don't want to use in plots that we're making, we can grab it and say, well, yeah, that didn't work that day for some reason. We don't want that. So let's mask it. Oops, we went one too far. Let's unmask that. So we go back and unmask it. And so if it's masked out, when you make a graph, it won't show up in your graph. If you do calculations, for example, one of the calculations we'll do is we'll do statistics. So let's find the statistics of what's going on right there. I use this all the time. So column statistics, it tells me the minimum value, the maximum value, sum, points, mean, median, standard deviation, variance, and so on. So you can see so statistics that you would like to know of this data set. And so I could just grab a piece of that and say, let's just look at this. So there's the statistics, only 9 points in there now. Let's try to just grab what's masked out and see what it says to us. Uh-oh, nothing. There's nothing there because there are no data points because those data points are masked out. They're not used. So you can see how that works. Sometimes you'll have something highlighted that is all masked out, and you'll wonder why it's not doing anything. You're not getting anything on your graph, or you're not getting anything on your data statistics like we were just looking at. And it's often what I've found when I have that issue is that it has to do with the fact that I've just highlighted something to mask it out, then I don't unhighlight it, and that's the only portion that of data that's trying to work with, and there's just nothing there because it's all masked out. So anyway, that's what we got looking on here. So that's how we would use masking. We come back up here and we've looked at statistics under here. One of the things that I do a lot is I bin data, and you can see more of that in the histogram making video that we have out there. So I won't do much of that right here, but you can play with the number of bins and the range of the bins and so on, and see. Obviously, in this one, there was an overflow error right there, so you see why that's out there. But you can actually bin that data. I'm sending you to a different video, the histograms and KaleidaGraph video, to see about binning that way. The transpose I'll use somewhat, so it wouldn't be uncommon for me to have a data set and to say, let's actually just take this, and I'm going to do a copy and a paste out in here, and then I'm going to transpose this. And you can see now it pushed this out. That messed up all of my data because I had data in all of that stuff out there, but it took my data and transposed it. What I'll do is I'll make a new window for you to be able to see that. So typically I would have something in here like 3, 8, 9. And then I'll say, hey, let's transpose that because I want to paste it in someplace else, but I want it to be a row and not a column. And so I'll come up here to functions and I'll say, let's transpose it. And you see you've got what you want right there. So anyway, I will use the transpose function. The other thing that I will use is an ascending sort and descending sort. Almost always when I'm doing a sort, what I want to do, you have to grab a column. And what I want to do is I want to keep this data associated, right? I mean, that magnitude of the star is associated with that Julian date, and that day of our data run, and that actual calendar date of our data run, and so on. So this is an associated data set. I don't want to lose that. So if I want to find out what the brightest, the 10 brightest values for this star are right here, I will do a ascending sort. Remember, the lowest number in magnitudes, well, maybe you don't know, the lowest number of magnitudes is brighter. So if I want to find the brightest values, I'm going to do an ascending sort. And so I'm going to say, let's do all of those. And that way it kept the data together. And it tells me my star, of all of the things that we looked at, my star was the brightest on March 25th, 2010. Every other measurement we made was fainter than that. And it also tells me, that the 10 brightest, I want to find out what the average of the 10 brightest values are, 5 brightest values are right there. I can do a statistics and say, the 5 brightest brightest measurements for this star turn out to be 13.281 is the mean magnitude for that star. So that's interesting to know. The other thing that's interesting to know, for example, is I look at this and most of these nights are masked out, meaning they didn't pass our photometric quality test. So it tells me, it's a little warning flag in my head that says, on the nights that we have poor, low quality data, we tend to overestimate the brightness of this star. It looks like to me, the brightest values are clustered up there where we have lots and lots of these masked out values. So we have fewer, we had a whole bunch there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 out of 15 or so right there that are masked out. Down later on, you just get a few that are masked out here or there. You get long runs of them where they're not masked out so much, Instead of 10 out of 15, you get 3 out of 15 or 4 out of 15 or something along those lines, 1 out of 20. So anyway, that's something for me to watch when I'm doing that. Now, you might have noticed we could have done this sort. We could have said, hey, let's do this ascending sort. But I also want to have, suppose there are 2 values that are the same. You see right down there, 13.503, 13.503, 13.503. I want to have a secondary sort on there. And I want, on the days that have the same magnitude, I want to sort them by day of the data run. So I'll put that in as the second key, and I want to have an ascending sort there too. So now that's good. I still have to remember to say all. So I'm sorting all of the data columns. I'm not screwing up and unassociating my data that's associated with one another. And there we go. And now we go to our 13.500s, and these should be in the order of the day of the data run that we put in there. So as our secondary run doesn't seem like it did that there. 13.5. Yeah, I'm wondering if that data may have more data out there. There may actually be more digits than what we're actually looking at right there. So it may be that those look like they're the same, but they're not the same. So it's possible that we had a value there that looked like it was the same, but it was different out to digits that we couldn't see in there, is what caused that to look that way. So this is a way we might manipulate these data sets somewhat up here. I think that's enough for what we want to do in there. Let's look briefly at macros. One of the things we like to do with macros all the time is we like to put series in. And so we might put unit series in out here. Note what's going to go on when we do that. Let's go out here to a data column that doesn't have anything in it. And let's say, let's put in a unit series. There it goes. There's our unit series. That might be something that we want to use for a calculation or we want to manipulate. Let's see what happens if we put in 2, 4, 6, and then let's say, let's put a series in there. I'm just curious what happens if I put a series in that column. Oh, look at that. It continued what I had started, 2, 4, 6, 8, 10, 12. Well, that's very helpful. That's something that's useful for us from time to time. Let's see what happens if we try a random number generator. Okay, bunch of random numbers. I don't know how random they actually are, but a bunch of random numbers got put into that column. So now, I mentioned in another video sometime where we were doing curve fitting that if I'd wanted to put noise in the data, that's how I'd put noise in the data, is I would take a random number, multiply that random number by some value to scale it to what I want and add it to my data that I had over in the other column. So I could have done that to add noise to the data that way. So the random number generator might be useful to you. You can take integrate areas and integrate curves, and you can take derivatives of these sorts of things. I think we won't do that. We'll save that for a future video if we want to do that, and say let's play with that in the future. That's something that we might find useful if we do this, but we might not. I don't know. I'm not paying any attention to what I'm doing here. 0. Y column is 1. Oh, I need an XY function if I'm going to integrate. If I'm going to take a derivative, I need something as a function of something else, and I don't have something as a function of something else. But anyway, it was not our intention to talk about that here today. We've done enough, sort of getting the basics down of what we want to do in KaleidaGraph with our data file. So I think we'll stop that here right now and save some of the more advanced stuff for a future video. So hopefully that's helpful for you, and we will have more. So see you later, everybody.